Problem on single line to ground fault, line to line fault, and double line to ground fault through a fault impedance that is here J2 ohms. The problem statement goes like this. A three-phase generator with an open circuit voltage of 400 volts is subjected to an LG fault through a fault impedance ZF. This is the derivation number 4. That is single line to ground fault of an unloaded generator through a fault impedance ZF. This is J2 ohm. Determine the fault current if J1 is equal to J4 ohm, that is the positive sequence impedance is given, negative sequence impedance given, and zero sequence impedance given. Repeat the same problem with the same data for line to line fault and double line to ground fault. Here you have to find the fault current. Already we know the values of fault current. How the derivation already we completed. Now first we will solve one by one. First we will solve LG fault. For LLGfault, we know the interconnection of sequence network. It goes like this. In a single line to ground fault, with or without fault impedance, the circuit remains same except this fault impedance ZF. Now, as we know, in a single line to ground fault, positive sequence impedance that is Z1, negative sequence impedance that is Z2, and zero sequence impedance that is Z0. They are in series. They are in series. Hence, the current flowing through also the same. IA1 is equal to IA2 is equal to IA0, and EA1 is equal to EA. This voltage is given here. That is 400 volts is given here. Given out here. First of all, you know in a single line to ground fault the fault current equation is final equation we derived is I fault current I 3 times IA naught 3 times IA naught. To get that, what you have to get? You have to get the value of IA naught. You know IA naught is equal to IA1 is equal to IA2. From this diagram, if we apply KVL, what you are going to get the equation IA naught is equal to IA1, IA is equal to IA2 is equal to EA divided by all these are in series Z1 plus Z2 plus Z0 plus 3 times ZF. You remember here the value of ZF is given J2 here. Now here the impedance is 3 times ZF. This becomes 3 into J2, it becomes J6 ohms. That you have to first you have to find. In this case, IA1 is equal to IA2 is equal to EA divided by Z1 plus Z2 plus Z0 plus 3 times ZF. Substitute here. E is 418 angle of 0 divided by root 3 you have to make. Divided by root 3 you have to make. That is per phase. The line voltage is given. You have to convert into per phase value here. That is 400 by root 3. That's the one thing you have to keep it in mind. Next, add here 4 plus 2 plus 1 plus 6. You will get minus J 17.765 ohms. This is the current. That is the positive sequence current is equal to negative sequence current is equal to zero sequence current. Fault current is 3 times IA naught. Take the magnitude 3 into 17.765. This the fault current when in the power system there exists a single line to ground fault through a fault impedance that becomes 53.295 amps. Now with the same problem with the same data we go with finding the fault current for line to line fault. First you write the interconnection sequence as we know here. Here IA1 is equal to minus IA2. IA1 is equal to minus through a fault impedance that is ZF as already we seen in the derivation. And here IA0 is equal to 0, VA0 is equal to Z0. It does not come into picture here. First of all, you want to find the fault. Here you know the fault current equation for line to line fault is IF is equal to root 3 times IA1. Root 3 times IA1. You have to find IA1. How what is the formula? IA1 is equal to minus IA is equal to EA divided by these two are in series Z1 plus Z2 plus ZF. ZF is because through a fault impedance. First you find the value of IA1 is equal to EA divided by Z1 plus Z2 plus ZF. Substitute the values, you will get 28.87 amps. Now the fault current is root 3 times fault current is root 3 times IA1. Substitute the value of IA1 15. This is from the derivation already we computed. Similarly, with the same data you find it for LLGfault. LLGfault Z1, Z2, Z0 are in parallel, and between Z2 and Z0 you know the impedance that is a fault impedance that is 3 times ZF. That becomes J6 ohm that comes into picture here. These will be in series in parallel and in series with this Z1. You have to find the total impedance that is EA divided by total impedance. You are going to get the value of IA1. You know the fault current here also 3 times IA0. The fault current in a double LG fault with or without fault it is 3 times IA0. You have to get the value of IA0. First, to get the value of IA0, you have to get the value of IA1. Here you have to take IA1 as total current. That is IA1 is equal to EA by this Z1 plus these two are in parallel. That you have to get it IA1 is equal to Z1 plus Z2 into Z0 plus 3 times ZF. This already equation. Here you will get IRF IA minus J 41.57 amps. Now we require IA note only. No, not necessary to calculate here IA2. We require IA note only. IA note is equal to total current multiplied by opposite branch voltage, that is Z2. You have to Z2 plus Z0 plus 3 times ZF. Z2 plus Z0 plus 3 times ZF. Substitute, you will get 9.24 amps. Now you get it here. Fault current, 3 times I know, take the magnitude, it becomes 27.72 amps. Hence we calculated the fault current for different types of fault with fault impedance, for single line to ground fault, line to line fault, and double line to ground fault.